All right, first, they're going one at a time, in order. Person 1 will toss a coin, then person 2 will toss a coin, then 3, and if no heads have been tossed, then we start over again, and we keep going until a head is tossed. So when person 1 tosses a coin, the probability that they tossed a head is 1/2. We assume that a head was not tossed, so the second person goes. So the chance that the second person is tossing a head is, there's a 1/2 chance that the first person did not toss a head, and then there's a 1/2 chance that the second person does toss a head. So that's going to be a 1/4 chance. So if neither of them tossed the heads, there was a tails and a tails, then we need to know what the chance is that the third person tosses the first heads. So there's a 1/2 chance that person number 1 didn't, and person number 2 didn't, and now when person 3 goes, there's a 1/2 chance that they toss a head, which is a total of 1/8 probability. Now this is also the probability that all 3 of them tossed a tails. Tails, tails, and tails. So the chance that there's no heads yet and person number 1 tosses the first heads will be 1/8 times the probability that their toss is a heads. You can see that it just goes up by powers of 2. All right, so next we're going to look at a pattern for person 1's probabilities, and then we'll look at a pattern for person 2's probabilities, and then person 3's probabilities. So the probability that person 1 is the first person to toss the heads is the sum of these probabilities, because if the heads are never tossed, then we just keep on adding these, but eventually they're going to get tossed. So this is the probability that they'll get the first heads, and these are geometric series. So we can sum up these geometric series. In every single case, we can say that they're geometric, and we can say that the absolute value of R is the absolute value of 1/2 to the third, because they get multiplied by 1/2 to the third every time, every person. That's equal to 1/8, which is definitely less than 1, so they converge. And person 1's converges to 1/8. Person 2's converges to the first term over 1 minus the common ratio of 1/8, and person 3's converges to the first term divided by 1 minus the common ratio of 1/8. So person 1's first term was 1/2, and person 2's first term was 1/4, and person 3's first term was 1/8. Now we needed to consider infinite series because it's definitely possible that the first tails wasn't tossed until, say, the millionth toss. Highly unlikely, but definitely within the realm of possibility. And therefore, we needed to consider the infinite series of every possibility of them being the first person to toss the heads. And the infinite series will definitely cover every possibility of somebody being the first person to toss the heads. Notice that the sum of the probabilities is 1, because there's a guarantee that somebody will eventually toss the first heads, and that's why there's a 100% chance that eventually it'll be either person 1, 2, or 3. And these are the respective probabilities. Person 1 definitely is the odds favorite.